Hello, friends. This is Bhattacharjee Sir from Core Chemistry to the Point. Today, our topic of discussion is Grignard Reagent. So, let's get started. So, हम लोग देखते हैं ये ग्रिग्नार्ड रिएजेंट कैसे आया, कहाँ से आया और ये रिएजेंट बनाने के पीछे सोच क्या थी। अम, मान लेते हैं एक कंपाउंड AB is there. Here is positive charge on A and negative charge on B, and we want to um, uh, attach CN to A. For that reason, we'll take KCN and there'll be simple double displacement reaction and we'll get this product very easily. Okay, KB. So, how we are attaching this CN minus to A plus? Because हमारे पास कुछ reagent है like KCN who can supply CN minus. That's why this reaction is possible. Similarly, अगर हम लोग A के साथ some other reagent or other group we want to attach, like हम लोग ले लेते हैं I want to attach OCH3, तो हम लोग क्या करेंगे, एक reagent लेंगे NaOCH3. So this is minus, this is plus, and in that case you will again get OCH3 plus NaB. Okay, so इसका मतलब है हम लोग जो भी अटैच करना चाहे उसके हिसाब से एक रिएजेंट को हम लोग चूज कर लेते हैं, या ऐसा रिएजेंट हमारे पास मौजूद है। अभी आपको अगर मैं बोलूं कि A प्लस के साथ आप अगर कोई एल्काइल ग्रुप को लगा दो, सपोज आई एम आस्किंग टू मेक CH3A फ्रॉम देयर, तो आप क्या सोचोगे? आप बोलोगे सर ऐसा मेरे पास कोई रिएजेंट तो है नहीं जो CH3 माइनस को सप्लाई करे। सो अगर कोई ऐसा रिएजेंट है जो CH3 माइनस को सप्लाई करे, ऐसा करके, ठीक है? तो हमारा ये बात बन जाएगा। अभी सवाल है, ये जो रिएजेंट मैंने आपको यहाँ पे दिखाया, वो बेसिकली कार्बन के साथ कोई तो ग्रुप जुड़ा हुआ है, जिसमें एक पोलैरिटी दिख रहा है, and this polarity is bringing negative charge on carbon or alkyl group, and that is making it reactive. So with that purpose हमारे जो ग्रिग्नार्ड रिएजेंट है वो प्रिपेयर हो गया। तो ग्रिग्नार्ड रिएजेंट प्रिपेयर होने के पीछे जो कहानी है, साइंटिस्ट का नाम था विक्टर ग्रिग्नार्ड। तो ये साइंटिस्ट 19,000 में ये ग्रिग्नार्ड रिएजेंट को उन्होंने बनाया। ओके, सो व्हाट ही डिड, he took one alkyl halide, okay, and he put magnesium and one ether he added, okay, and then finally he got this RMgX. Okay, so how this has been formed? Actually, it goes by free radical reaction mechanism. Basically, ये जो आपके जो X के जो odd इलेक्ट्रॉन आपको दिखाई दे रहा है, he will come and will combine with the odd electron or one electron present on the magnesium, and R group will go there and will combine with the other electron present on the magnesium. So as a result, you'll get this particular मॉलिक्यूल। ओके, सो आप अगर देखोगे यहाँ पे तीन चीज यहाँ पे बहुत जरूरी है। एक तो पहली तो बात है, एक है हमारे एल्काइल हैलाइड ग्रुप, दूसरा है हमारे मैग्नीशियम ग्रुप, एंड तीसरा है ईथर ग्रुप। ओके, सो हम लोग अगर कोई एल्काइल एल्काइल ग्रुप हमारे पसंद के हिसाब से लगाना चाहेंगे तो हम लोग लगा सकते हैं। तो अभी एल्काइल ग्रुप क्या-क्या हो सकता है, क्या-क्या वेरिएशन हो सकता है? लेट मी टेल यू, इट कुड बी methyl group, or I'm talking about it could be methyl group, it could be ethyl group, okay? It could be propyl group, it could be secondary alkyl group, it could be tertiary alkyl group, it should be phenyl group, it should be vinyl group, it should be allyl group, बेंजाइल ग्रुप. सो आप बहुत टाइप के एल्काइल ग्रुप को यहाँ पे लगा सकते हो, ठीक है? ऑफ कोर्स देयर आर सम लिमिटेशन आल्सो in choosing different alkyl groups, such as there is a little problem with this, the little problem with this. So I'll discuss it little later. So I hope you have understood that हम लोग कुछ भी alkyl group यहाँ पे हम लोग लगा सकते हैं. Alkyl, aryl, विनाइल, एलाइल. सो सारे कुछ हम लोग यहाँ पे लगा सकते हैं, ठीक है? तो ये बात हमारे लिए क्लियर हो गया. अभी कम टू द ईथर पार्ट. ये ईथर जो है, ये हम लोग क्या ईथर चूज़ करें और क्यों करें ईथर को चूज़? देखो, ईथर जो होते हैं, वो बेसिकली बीच में एक ऑक्सीजन होगा, उसके बगल में 2 एल्काइल ग्रुप होंगे, ठीक है? और हमारे लिए जो कॉमन अवेलेबल ईथर होता है, वो डाई इथाइल ईथर, ओके? सो ये ऑक्सीजन दैट इज़ डाई इथाइल ईथर, ओके? सो इसको हम लोग यूज़ कर सकते हैं. एंड अनदर हम लोग ईथर यूज़ कर सकते हैं, दैट इज़ टीएचएफ, टेट्राहाइड्रोफ्यूरन, ओके? ये 2 ईथर हम लोग यूज़ करते हैं, बट लैब में जो मोस्टली यूज़ होता है ये वाला. दिस ईथर इज़ दिस, बेसिकली आई एम ड्राइंग इट अगेन. दिस ईथर आई एम टॉकिंग अबाउट, ओके? सो अभी लेट्स ट्राई टू अंडरस्टैंड why you are choosing ether. There might be so many reagent, I mean solvent, but why we choose ether in that case? Basically, ether gives a kind of inert environment for magnesium. Magnesium is highly reactive. So अगर मैं magnesium को देता हूं तो magnesium immediately can react with oxygen, then moisture, okay, moisture. सो अभी क्या होता है, हम लोग जब ईथर देते हैं, देन ईथर एक्चुअली प्रोटेक्ट दिस मैग्नीशियम, ईथर प्रोटेक्ट दिस मैग्नीशियम फ्रॉम द रिएक्शन विथ ऑक्सीजन एंड वाटर. ईथर देखिए, ईथर थोड़ा सा भारी होता है एंड क्या करता है, सारे ये जो हमारे एनवायरनमेंट में जो ऑक्सीजन या मॉइस्चर होगा उसको डिस्प्लेस कर देगा. एंड फाइनली आपके जो कंटेनर होगा, कंटेनर में आपके जो ईथर होंगे, ईथर के अंदर कुछ नहीं होगा, सिर्फ मैग्नीशियम बचा हुआ रहेगा, ठीक है? सो मैग्नीशियम, नाउ यू आर प्रोटेक्टिंग मैग्नीशियम फ्रॉम other substances from any sort of reaction. That is the first point. Coming to the second point, that once this Grignard reagent is formed, this one, then again what it does, it again protects this particular Grignard reagent by the solvation process. अभी आप बोलेंगे ये क्या हो गया सर? देखो, पहली तो बात है, ये Grignard reagent is highly reactive, ओके? सो वो क्या करता है, चारों तरफ से वो उसका एक लेयर बनाता है चारों तरफ से, ओके? एंड डज नॉट अलाउ एनी CO2, water, oxygen, etc. come in contact with the Grignard reagent and to do the reaction, okay? So ये ईथर हमारे लिए बहुत काम की चीज है to make the Grignard reagent. So I hope that is understood to you. Now question arises, how to understand the reactivity of Grignard reagent. Okay. Now, let's try to understand the bond present in Grignard reagent. Basically, Grignard reagent में जो बॉन्ड है, दो बॉन्ड है मैग्नीशियम के साथ. एक है एल्काइल ग्रुप के, एक है हैलोजन ग्रुप के. This halogen could be Cl, Br, I. Avoid fluorine. It is highly reactive, so don't use fluorine. And alkyl group already I have told you. Now, question arises, ये जो आप बॉन्ड देख रहे हो, ये more polar and it is lesser polar. Okay. Now, question arises, negative charge will appear here and negative charge will also appear here, and here positive charge will appear. So you can see the Grignard reagent is such a reagent which is capable of releasing X minus as well as R minus. Okay. So अगर X minus भी रिलीज हो रहा है, R minus भी रिलीज हो रहा है, तो how come only R minus is coming out from the Grignard reagent and doing all sort of reaction? देखो, आपको मैं एक समझाता हूं. आपने ब्लीचिंग पाउडर के नाम सुना होगा, राइट? तो ब्लीचिंग पाउडर के केमिकल फॉर्मूला जो है ना, अगर आप सर्च करोगे बुक में, आपको मिलेगा, ये मिलेगा, और आपको ये भी मिल सकता है, कैल्शियम Cl प्लस कैल्शियम OCl. सो बेसिकली यू विल फाइंड ये दोनों का जब आप कंबाइन करते हो तो आपको बेसिकली ये मिलता है. या आप उल्टा भी सोच सकते हो, इट इज डिस्प्रोपोर्शनेटिंग एंड गिविंग दिस वन. सो बेसिकली यहाँ पे देयर आर टू एनायन, वन इज दिस एनायन, of course minus 1, and there is also Cl minus, there is also minus 1. So basically when calcium is attached to it, OCl minus as well as Cl minus, then it is called bleaching powder. अभी आप सडनली बोलोगे सर ब्लीचिंग पाउडर का क्या काम है सर यहाँ पे ग्रिग्नार्ड रिएजेंट में. लेट मी शो यू. देखो, ये जो हमारे ग्रिग्नार्ड रिएजेंट है, बेसिकली आर एम जी एक्स आप देख रहे हो, इससे बेसिकली कॉम्बिनेशन ऑफ आर एम जी आर एंड एम जी एक्स एक्स, ये दोनों को अगर कंबाइन करोगे तो जाके ये बनेगा. ओके. सो basically he can release R minus as well as X minus, but of course R minus dominates because R minus का जो न्यूक्लियोफिलिसिटी या बेसिसिटी होता है X माइनस से बहुत बहुत ज्यादा होता है. ठीक है. आपको एक छोटा सा एग्जांपल से बताता हूँ. देखो, मान लेते हैं हमारे पास कोई तो रिएजेंट है, ए बी मान लेते हैं. ठीक है. और ये प्लस है, ये माइनस है. ठीक है. अभी ग्रिग्नार्ड रिएजेंट आपको क्या सप्लाई कर रहा है? आपको सप्लाई कर रहा है आर माइनस एंड एज वेल एज एक्स माइनस. आप बोलोगे दोनों कर सप्लाई जब कर रहा है वो किसी के साथ भी रिएक्ट करेगा. देखो, अगर वो इसके साथ आप मान लेते हो रिएक्ट कर रहा है, तो आपको बनेगा क्या? आर एक्स. बट एक्स इज ए वेरी गुड लिविंग ग्रुप, so immediately this R minus will come into the field and it will react with this, and this X minus will go out. So finally you will be getting RA. अभी सवाल है, the moment RA is formed, this bond is very very stable bond and strong bond, stable bond. Understood? तो that's why what I'm trying to say कि आपका ग्रिग्नार्ड रिएजेंट से जो इफेक्टिव जो नेगेटिवली चार्ज पार्टिकल रिलीज होता है, दैट इज ओनली एंड ओनली आर माइनस. आई होप यू गॉट दिस पॉइंट. नाउ कमिंग टू द its reactivity pattern and style. So let's try to see this its reactivity style. So you can see now I have written down Grignard reagent is behaving like base and sometimes it behaves like nucleophile. अभी सवाल होता है बेस की तरह बिहेव कब करता है? ये तभी बिहेव करता है बेस की तरह जब दूसरा मॉलिक्यूल जो है ही कैन रिलीज H प्लस और इट हैज एक्टिव हाइड्रोजन और H plus in the molecule. Okay. So जहाँ पे भी H प्लस थोड़ी सी भी H के ऊपर प्लस करेक्टर आ जाता है, ग्रिग्नार्ड रिएजेंट तुरंत उसके साथ रिएक्शन कर लेता है। तो हम लोग थोड़ा-थोड़ा करके देखते हैं, तो फर्स्ट ट्राई टू अंडरस्टैंड इसका रिएक्टिविटी एज़ अ बेस। ओके? सो पहला रिएक्शन है, हम लोग ग्रिग्नार्ड रिएजेंट एक सिंपल सा लेते हैं, CH3 MgBr। ओके? एंड एक वाटर लेते हैं। सो नाउ लेट्स ट्राई टू अंडरस्टैंड इसके ऊपर नेगेटिव चार्ज आएगा। ऑफ कोर्स इज़ अ पार्शियल नेगेटिव चार्ज। बार-बार पार्शियल लिखेंगे तो थोड़ा टाइम चला जाता है, तो sometimes I'll write directly negative or positive charge. So I hope you'll understand that. And there is some positive charge and there is negative charge. Okay. So now this negative charge will come out and will react with this, and this negative charge OH minus will come out and will attach with magnesium. So finally you are getting CH3 and this new H getting attached, and of course जो ग्रिग्नार्ड रीजन का MgBr के साथ जो चिपक गया हमारा OH। ओके। सो दिस इज द रिएक्शन, एंड जितने एसिडिक हाइड्रोजन है सारे वैसी रिएक्शन करने वाले हैं। तो देयर इज नो एज सच स्पेशल केसेस। सो फिर भी दो चार और देखते हैं। जैसे ये हमारा ग्रिग्नार्ड रिएजेंट है, CH3 MgCl ले लेते हैं। अभी एक एसिड ले लेते हैं, एक कार्बोक्सिलिक एसिड ले लेते हैं। ठीक है। So this is the carboxylic acid, and this is plus, this is minus, this is minus, this is plus. I hope you can see this. So हम लोग अगर कट करके भी करें तो ऐसे भी आप कर सकते हो। सर और सेम थिंग। तो ये इसके साथ चिपक जाएगा और ये जो नेगेटिव है इसके साथ चिपक जाएगा। ठीक है। तो अगेन यू विल बी गेटिंग CH3H and here MgCl और नीचे आपका OC डबल बॉन्ड O CH3, राइट। सो ऐसा अगर लिस्ट बनाएंगे बहुत सारे मॉलिक्यूल हो सकता है, उसका एक कॉमन सा लिस्ट में बना देता हूँ अभी। So just I have made a big list of all the reaction of Grignard reagent with the acidic hydrogen. So you can see this. This is alcohol. I hope YH plus has come on alcohol. It is very clear to you. Coming to this molecule that is little special. Now आप बोलोगे ये तो सर कार्बन हाइड्रोजन बॉन्ड है, उसमें कैसे एसिडिक हाइड्रोजन आ गया? Actually, when it loses this H plus, this negative charge, whatever it will come on this particular molecule, it will go into resonance and it will produce aromaticity in the molecule. That's why it's a acidic hydrogen. Okay. And this is a nitrogen hydrogen is a polar bond. I hope you understand that nitrogen hydrogen polar bond, nitrogen hydrogen. And carbon hydrogen, how is it polar? Because this carbon is sp hybridized, is a highly electronegative carbon atom. So that's why it pulls electron and produces sufficient positive charge on hydrogen. That's why there is a acidic character coming. Of course, there's a phenol. This is cyclic amide and positive charge coming on hydrogen. So this is all about how Grignard reagent is behaving like uh, a base and abstracting proton or H plus to form alkane such as methane, ethane, propane, etc. Now let's try to understand how Grignard reagent behaves like nucleophile. So in that case, Grignard reagent basically it reacts with some electrophilic center, and electrophilic center can be various types. One could be C double bond O, that is you can see it in aldehyde, ketone, etc. Acid halide, ester. One could be C triple bond N, okay, S double bond O. Then you can have it like O. This is also nucleophilic center. Okay. So it could be like this also. It could be phosgene also. So what you need to understand, this all these bonds, whatever I have written down, they have positively charged center and negatively charged center. So that's why nucleophilic reaction is possible with them. Okay. Now let's try to see reaction one by one. Our most important reaction with the Grignard reagent is with um, aldehyde and ketone is most important. So we'll focus more on that part. So let's try to see few reactions. Before showing this reaction of Grignard reagent with aldehyde, ketone, or there are derivative, one point I need to make it very clear. When you find molecule has bond with carbon or hydrogen, then whatever um, R minus will be coming out from the Grignard reagent, it will be getting attached here, and this bond will break, and this will be attached with the remaining MgX plus. Okay, so you'll be getting this molecule OMgX, and here CH, and here the new R, what is coming from the Grignard reagent. And of course, after the acidic hydrolysis, how acidic hydrolysis will happen? You can write water like that. Okay. There is a positive charge, there is a negative charge, there is a negative charge, there is a positive charge. So they will react like that. Okay. So finally, we'll be getting H, C or H, C or H, and here is the R group. Okay. And of course, Grignard reagent will look like this. OH, X. Okay. So this is the first important note I have given to you. Now, second point is that if you have carbon, carbonyl carbon, and you have a carbon hydrogen there, and you have a good leaving group. Now, what could be the good leaving group? It could be halogen, could be NH2, could be OR, could be OC double bond OR, etc. Okay. So in that case, when R minus coming out from the Grignard reagent will attack here, then what will happen? Now, rather breaking this pi bond, you need to break this bond and it will combine with the MgX of the remaining part of the Grignard reagent. Then finally, we will be getting HC, C double bond O, then R group, and of course, XMg, and remaining part, there is a this good leaving group wala part. So let me show it with some different ink. इसको हम लोग ऐसा दिखा देते हैं, ऐसा करके लिविंग ग्रुप करके एक दिखा देते हैं, ठीक है? उसमें ये लिविंग ग्रुप अटैच हो जाएगा. I hope you understood that. Now third case, you'll find that there could be on both the sides, it could be living group. Okay, here's a living group, here is also living group. So when Grignard reagent will react, then R minus will go, then it will come out, then you'll find one living group is there, then C double bond O on R. Then next time another reaction will happen, it will attack here. So another living group will go out, and R C double bond O R molecule will be getting. Okay. Now, my point is that reaction will not stop at this point. If you give more amount of Grignard reagent, it will react further. So, which I will show it later on. Okay. Now, if you have understood these 3 points, then we'll start proper reaction. Okay. So, let's take one aldehyde. Now, I hope you know this is positively charged point, this is negatively charged point. Now, I am giving one Grignard reagent, CH3, Mg, Cl. Now, it will come out as a negatively charged particle and will attack here. And according to our note, that this bond will break and it will take this magnesium and it will be like this. Okay. And later on, hydrolysis will take place. This is plus, this is minus, minus, plus. So it will break down like that. And what will happen with Grignard reagent? उसके पास एक नया जो ग्रुप आ जाएगा, that will be OH. Okay. Now ये जो आपने पैटर्न देखा है रिएक्शन की, ये कीटोन के साथ भी एग्जैक्टली वही होने वाला है. तो आई होप you can do this reaction, but still let me show you how it will happen. So here is the reaction of ketone with Grignard reagent. Exactly same kind of reaction, only hydrogen is replaced by this CH3 group. Rest of the things are same. Okay. Now let's go to the another reaction. Now अभी अगर हमारा रिएक्शन में कोई लिविंग ग्रुप आ जाता है, suppose you are getting OCH3, okay, that is called ester. Okay. Now in that case, जब भी आप Grignard reagent दोगे, then what will happen? This will come out and it will hit here, and according to our note, it will come out and it will combine with magnesium. So finally, you are getting CH3, C double bond O CH3. Okay. And later on, आप फिर दोबारा Grignard reagent दोगे आप इसमें, then MgBr, then again it will come out and it will attack here, and of course it will go up, will combine with the magnesium. Okay. ये प्लस है, ये माइनस है. सेम कहानी बार बार मैं रिपीट कर रहा हूं. So finally you will get O MgBr CH3 CH3, and finally after acidic hydrolysis you will get tertiary alcohol. Okay. I hope this reaction is clear to you. अभी हम लोग क्या करते हैं, another type लेते हैं. अभी हम लोग दो लिविंग ग्रुप रखते हैं. ठीक है. यहाँ पे हम लोगों ने Cl रखा, another Cl. Now I am taking Grignard reagent. Now आपको कहानी थोड़ा थोड़ा अभी समझ में आने लगा शायद. तो अभी क्या होगा, ये जाएगा, महाशय यहाँ पे अटैक करेंगे, ये निकल जाएगा, निकल के इसके साथ चिपकेगा. ठीक है. तो यू आर गेटिंग Cl, C डबल बॉन्ड O C3, जो नया वाला C3 आया. ठीक है. सो देयर विल बी अनदर रिएक्शन, CH3 MgBr. Now it will come out and hit here. Again, it's a living group. It will come out and of course it will combine with the magnesium. ठीक है. यहाँ पे दिखा देता हूँ, थोड़ा सा अनटाइडी लगेगा, but I hope you can understand that. So you are getting this molecule. Okay. Now it will further react with another Grignard reagent, and Of course, after acidic hydrolysis, I hope you understand, is going to form tertiary alcohol. Okay. Yeah. Now, it's again similar kind of reaction. So that's why I have paused it and wrote the reaction. Sorry. So, um, so how this is nucleophilic addition reaction is going on now? Taking little different type like CO2 gas, SO2 gas, SO3 gas, etc. Let's see how this reaction goes on. Now you see there is a positive charge on carbon, negative over here. There is a negative charge, there is a positive charge. Okay. Now this negative charge will come out, will hit here. It will come up and it will take this magnesium. So finally you'll be getting O डबल बॉन्ड सी, यहाँ पे लग गया CH3 और दूसरा वाला ऑक्सीजन के साथ लग जाएगा MgBr. Okay, this is minus, this is plus, and if you do acidic hydrolysis, then this is plus, this is minus. So it will be like that. Okay. So reaction with SO2 also shows similar kind of method, and finally you are also ended up getting an acid. Okay. Now let's see how it reacts with cyanide. Okay. So R C triple bond N, and you can see there is a positive charge, there is a negative charge, and you are giving one Grignard reagent here, MgCl. Okay. Now it will be coming out, hitting here. It is breaking down and taking this magnesium here. So finally R C N CH3, then MgCl. Now let's try to understand that this is plus, this is minus. Okay. So now when you do the hydrolysis, so what will happen? So it will break the bond like that at the middle. Okay. So you'll get double bond O, then NH2 MgCl. I hope reaction with cyanide also you have understood. Now I'm just telling you very important two application of Grignard reagent. Reaction with alpha beta unsaturated aldehyde ketone. Okay. So now we have 2 points for the reaction. One you can find it here and another here. Okay. This is the points for it. And here also the same thing. Now remember, when it is an aldehyde, then reaction will occur at this point only, at this point. So it is going here, attacking here, it is going up, taking this magnesium first, and later on it will take acidic hydrogen. Okay. So I'm just skipping that step and just writing this product directly. So you can see this CH जैसा था वैसा मैंने रख दिया उसको इंटेक्ट, बट इसी पॉइंट को मैंने चेंज कर दिया. That is, I am attaching Grignard reagent R group. Okay. Now, but when it is ketone and you have some catalyst cuprous ion you have given it, that is Cu2Br2. तो basically what happens, ये जो Cu प्लस है ना, वो क्या करता है, it forms a quite a stable bond or kind of intermediate with the pi bond here and decreases electron density across this bond. Now you need to understand when electron density decreases, then हमारे जो पॉजिटिव चार्ज है यहाँ पे आते हैं kind of, because this positive charge can be stabilized by this resonance by this benzene ring. यहाँ पे नहीं आ सकता है पॉजिटिव चार्ज, यहाँ पे बिल्कुल नहीं आ सकता है, बिकॉज ये जो एसाइल ग्रुप है इसे हाईली इलेक्ट्रॉन विथड्रॉइंग ग्रुप, एंड इट विल डिक्रीज द sorry, it will increase the positive charge density, and finally the reaction will be very difficult. So as a result, what you will find, this reaction will happen across this carbon carbon double bond. Okay, just I'm erasing that. Across this carbon carbon double bond, and you can see this, it is coming out and directly striking here. Okay, and it is going up and taking one H plus from acidic hydrogen or acidic water. So finally you are getting a ring. Okay, मेरा रिंग के अंदर गोला थोड़ा सा गड़बड़ हो गया, अभी ठीक किया. तो CH, तो नया जो R आया ग्रीन वाला R, let me show this R, then single bond, then CH, another H has come, एंड वो जो कार्बोनिल ग्रुप था ना, वो जैसा है वैसा ही रहेगा. सो मेरे हिसाब से इट कैन बी वेरी इंपॉर्टेंट इंफॉर्मेशन. ओके, नाउ एट द एंड लेट्स कम टू द some limitation of Grignard reagent and its application. So एक एक करके डिस्कस करते हैं. तो पहला जो लिमिटेशन है, आपके अगर एल्काइल ग्रुप एलाइल होगा, जैसे आपका CH2 डबल बॉन्ड CH, देन सिंगल बॉन्ड CH Mg Br, पकड़ लो आपके, ये आपके एल्काइल ग्रुप है. देन व्हाट विल हैपन, whatever you have taken this allyl group like that during the preparation. Okay, now it will come out from here and will react with this particular point. Okay, तो आपको लगेगा इसमें लिमिटेशन का क्या है सर, इट्स नॉर्मल रिएक्शन है. देखो इसका लिमिटेशन मैं क्यों बोल रहा हूं, क्योंकि जब भी आप इसको प्रिपेयर करोगे तो यू विल टेक सफिशिएंट अमाउंट ऑफ allyl chloride. Then once this is formed, then this allyl magnesium bromide again will react with the allyl halide and will form diallyl compound like that. So this is limitation. Okay, so similarly when you prepare Grignard reagent with the benzyl halide, okay, so this is our benzyl halide, and you are giving magnesium and ether ROR, then you will be expecting this Grignard reagent, okay, CH2 MgCl. But the moment it is formed, immediately it will react with this another benzyl halide, and finally it will come out. It will come out from here and will react with this, and it will break down. It will combine with the magnesium. तो again आपको एक प्रोडक्ट ऐसा मिल जाएगा. सो इसको हम लोग डाई बेंजाइल बोलते हैं, MgCl2. तो अगेन व्हाई आई एम कंसिडरिंग दिस एज ए लिमिटेशन, बिकॉज हमारे जब भी हम लोग ये ग्रिग्नार्ड रिएजेंट बनाते हैं, तो ग्रिग्नार्ड बनने के बाद तुरंत क्या करता है, जो व्हाट एवर लेफ्ट ओवर बेंजाइल हैलाइड बचता है उसके साथ रिएक्ट कर जाता है, एंड यू कैन सी द स्टेबिलिटी ऑफ दिस मॉलिक्यूल. इसे lot of resonance are there, and also whenever reaction takes place, this particular group has always high stability, and whatever positive charge will come during the nucleophilic substitution reaction, it will be also very stable because of the resonance of the benzene ring. That's why these products are actually unwanted product that will be formed without our even intention. So that's why this is a kind of limitation for us. Another limitation is that if you have dihalide, geminal dihalide, and you are giving Grignard reagent, that is magnesium for the preparation, then what you can expect, that you must be expecting that, sir, that will be the product. Mg will come here, then X, then here again Mg come X, but not. This is not the product. Actually, what will happen? This magnesium will undergo free radical reaction with this two halogen group at the geminal position. So MgX2 will be formed and they will form a double bond here. So finally, the product you are getting, it will be CH2, C double bond, C and MgX2. Another limitation is that if you have some leaving group at the beta position, suppose you have OC double bond O CH3. It's a good leaving group. And you have halogen here. Then you will be giving magnesium and then of course ether. Then you will get MgX O C double bond O CH3. Now remember, when this negative charge will come on this carbon, okay, this negative charge, whatever there, it will fall here and it will come out as a good leaving group. So finally, you'll be getting this molecule. So this is also another limitation. Similarly, if you have cyclic molecule like that, halogen, halogen, and you are expecting a very good Grignard reagent formation, but it won't, rather than you'll get double bond here. Similarly, if it is a benzene and you have halogen here, okay, and you are giving magnesium, ROR, then you will get finally a triple bond here. So it will be a benzene basically, and benzene is highly unstable. You must be knowing this. So I'm just showing this bond like that. So once benzene is formed, it will combine with another benzene as such, also formed by the same method, and they will combine together and form molecule like this. So these are few limitations. So guys, with that, it brings to the end of our lecture for today. And I hope you have understood everything properly. Um, Looking forward to seeing you in the next video with the same intensity and with a positive frame of mind to understand and learn chemistry precisely. Thank you for watching. So until then, take care. Bye bye.